To understand the meaning of p-value in hypothesis testing, let us take an example. In this example, let us conduct an experiment to toss a coin multiple times. Now we have two options. One, the coin may be fair or coin may be unfair. So we are trying to decide whether the coin is fair or not. That's a question we are trying to find the answer for. So till it is proven that there is some fault, we need to assume that the coin is fair. That's our null hypothesis H0, which says that the coin is fair. And the other way, the coin is unfair or it is biased. And to ensure that the second one is true, we need strong evidence that H0 is to be rejected. So to reject H0 or null hypothesis, we need strong evidence. Okay, let's begin our experiment. Let's start tossing the coin. So our first toss, we get a head. So probability of getting one head definitely is 50%, because we are assuming that the coin is fair. So 50% probability of getting head, 50% probability of getting a tail. Okay, let's toss it again. Second toss, we get head again. So getting two consecutive heads in two tosses definitely is 1 out of the 4. So the probability of getting two consecutive heads in two tosses is 25%. Third toss, one more head. The probability of getting three consecutive heads in three tosses is 12.5%. That is 1/8, 1 out of 8. Fourth toss, one more head. So the probability is 1 over 16. That's somewhere 6.25%. What about fifth toss? Fifth toss is also head. So getting 5 consecutive heads in 5 toss, the probability of getting that is 1 by 32. That is 3.125%. In the sixth toss, one more head. 6 heads consecutively in 6 toss. The probability is 1 over 64, that is 1.56%. Now first toss is head, second toss is head, third is head, fourth is head, fifth is head. So I think there's something wrong with the system. At least somewhere out of 6 toss, somewhere at least one time there could have been a tail, but all consistently getting head and head and head and head. Yeah, they think something problem with our system, or no, I don't know. So let me continue what would happen. So seventh toss is also head. Oh God. So definitely there should be something wrong with the coin. Now I can say that getting 7 consecutive heads in 7 tosses is less than 1%. 1 in 100 times, if you repeat this experiment once, this is possible, and this has been possible in just one set of experiment. So if we repeat this experiment of tossing 7 times, and if we repeat this 7 tosses 100 times, then in 100, one chance is there that all 7 are consecutively heads. So 1 in 100 is a very small fraction of possibility, and we are getting it all 7 heads. So definitely makes some confusion. It creates some doubt that the coin may not be fair. Yeah, it's possible that both sides are head. Very much possible. Just keep tossing any number of times. You keep getting head because both sides are head. Or some way it is designed such that all the time or majority of the time head is favored. Somehow it is done. I don't know how, but yes, it is possible that the head is favored all the time. So whatever it is, yes, one thing is sure, that being less than 1% of chances can make it believe stronger that the coin is not fair. So the null hypothesis was the coin is fair. So after 7 tosses, and in all 7 tosses, if we keep getting head and head and head again and again and again, then yes, we have strong evidence that getting 7 heads consecutively is just less than 1%. That is, more than 100 experiments are to be repeated to get this situation. So this is a very, very, very rare situation under normal condition. Therefore, we can conclude that the coin is not fair. So now we can reject the null hypothesis and claim the alternative hypothesis may be true, that it is an unfair coin. Yes, we are rejecting null hypothesis, but we are not saying that null hypothesis is wrong. And this is possible. Accidentally, it might have happened that all 7 tosses we may get a head. Possible even with a fair coin. But yes, there is confusion. So this confusion or this confusion is growing as we continue our experiments, and with more number of heads consecutively getting, our doubt is becoming more and more stronger, and our disbelief is getting stronger and stronger, and believing that the coin is fair is going down and down. Maybe after 7 heads or 6 heads, we can say that the coin may not be fair, so we can reject the null hypothesis. Rejecting null hypothesis doesn't mean that 100% surely we can say that it is unfair, but yes, chances of being unfair are very much more than chances of being fair, and hence we can reject it. So this everything is done on probabilistic basis, nothing is done on relative, on absolute basis. So that's an example we can use to talk of p-value. Here the probability is the one which we are talking of is p-value here. So this we can assume the probability as a p-value. The p-value of getting 5 tosses, 5 consecutive heads in 5 tosses is 3.125. So anything less than 3.125 means at least 6 times consecutively we are getting an head after tossing the coin. That leads us to reject the null hypothesis. The null hypothesis was saying that the coin is fair, but the experiment is forcing us to go against it, and it is making us to believe that the coin may not be fair, and hence we tend to reject the null hypothesis. So somewhere, most of the cases, 3% is the value we consider. So when this p-value is less than 3%, then we reject the null hypothesis. But more than 3%, we are not very much confident in rejecting it, though we are not sure that it is true. We can't say that the null hypothesis is true, but we don't have proper evidence to reject it if the p-value is more than 3% in this case. So commonly we call it a significance level alpha. So there is some significance level alpha for every experimentation, and that is decided by the experiment, nature of experiment, and the problem under which we are working. This significance level alpha is decided for the problem and for any given data or given experiment. If the p-value goes below the significance level, then we can reject the null hypothesis. If it is above, we can't reject null hypothesis, so we should go with the null hypothesis, like the criminal justice. So a person is innocent until proved guilty. So we need a strong evidence to prove that the person is guilty. So if you lack this evidence, then will be treated as innocent. So that is, if the p-value is greater than significance level, then it is null hypothesis is valid. If only when the p-value goes below significance level, only then the null hypothesis can be rejected. So that's it for now. This example, I hope, will clear the picture of p-value and what this null hypothesis is, what is the hypothesis testing now. So many more details to come, so please continue watching. Thank you.